Dear students, we are going to discuss the question asked from alternating current and inductance from JEE Mains 2021 in February shift. Okay, a total question asked in February. First question is like this: that we are connecting an inductor with some variable voltage, and the voltage supplied by you is simply 3T volt, and the inductor is of, let's say, some L coefficient of self-induction. Okay, now due to this voltage, if it start to grow, this solenoid will oppose this, okay, by inducing the voltage of L di by dt. And we know it very well that this point is A and this point is B. Then VA minus VB, if you go through this battery, you will say VA minus VB is 3T. If you go through above induced battery, you will say VA minus VB is L di by dt. Okay. What is the value of di by dt here? So di by dt is simply 3t by L, and di is equal to 3t dt divided by L. Okay. By integrating this term, we can find the value of current. The I will be like integration of 3t dt divided by L, the limit from 0 to 4 seconds. Okay. So 3 divided by L is common. T dt integration is t square by 2, and per square 16. 3 divided by 2L into 16 is there, and L is also 2. Okay. If L is 2, 2 into 2, 4, 4 into 4, 16 by 4, 4. And current at this moment will be 12 ampere. Now they want to know what is the current energy stored inside solenoid at this moment. Half Li square. Half L is 2 and I is 12 ampere. So 12 into 12, this value is here, and 144 joule will be the answer. Okay. This is the answer in printed form. Okay. Next, a transmitter circuit used for transmission of EM waves of wavelength 960 meter. Now see here, if you are using a transmitter which emits wavelength 960 meter, then the frequency is n equal to c by lambda. The speed of light is simply 3 into 10 to the power 8 meter per second, and lambda is 960. Solving this value, will get 1 by 32 into 10 to the power 7. Okay, and this frequency is generated by some LC oscillator, and LC oscillator is simply frequency 1 by 2 pi root LC. And they want to know what is the value of self-inductance L. Okay, so value under root LC is here 1 by 2 pi into 32 divided by 10 to the power 7. And if we make it square, LC is equal to 32 into 32 divided by 4. Pi square is 10 and 10 to the power 14. Okay. And if you remove C from here and take it downside, C is simply 2.56 into 10 to the power minus 6. So this value will be like 32 into 32 divided by 4 into 2.56. And here value is 10 to the power 14 into 10 to the power minus 6, 10 to the power 8. Okay. And this value like 100 divided by 10 to the power 9 and 10 to the power minus 7. I want to know what is the value of P into 10 to the power minus 8. So you can write as 10 into 10 to the power minus 8, and value of P will be like 10. Okay. Now they're saying the 220 volt supply is given to the primary circuit and 12 volt is taken out. So they are saying Vp by Vs, simple theory is Np by Ns. They want to know what is the number of turns in primary coil. This value they want to know. Number of turns in primary coil will be Np. Number of turns in coil, secondary coil was 24. Secondary output is 12 volt. Okay, DC is RMS value and 220 volt is also RMS value 2220. And NP will be like 24 divided by 12 into 220. Okay, cancel, and answer will be like 440. Next, they're saying that I wonder what is the quality factor of the circuit. Okay, quality factor of the circuit for LCR circuit is simply omega naught L by R. Okay, omega naught 2 pi N. L is simply 2 into 10 to the power minus 4 Henry, and resistance 6.28. You know it very well. 2 pi is also 6.2. You can cancel it. The frequency is 10 megahertz. So 10 into 10 to the power 6 into 2 into 10 to the power minus 4. This value will be like 2 into 10 to the power minus 4 into 10 to the power 7 and 2000. The quality factor of this circuit is 2000. It depends upon omega naught. That means inductance at resonant frequency divided by resistance of the circuit. Okay. Now the circuit question is very simple. They are connecting cell here, resistance. There are some inductor and resistance and inductor. You know it very well. At t equal to 0, due to inertia, you know, this inductor will try to oppose any change. Before closing the switch, there will no current. तो बाद में भी ये किसकी तरह behave करेगा? It will behave like open circuit. And if the circuit is open, this will not take part in the circuit. You can say this 2 and 2 are in series at only t equal to 0 moment. After this, there will some equation here. There will some current here. Okay, at t equal to 0 moment only, you can say I is equal to 9 and 2 are in series. The total resistance is 2 plus 2, 9 divided by 4 and 2.25 ampere. Okay. One more discussion is there. The resistance power consumption in the circuit is 16 watt, 10 to the power 5, 120. They want to know what is the value of resistance at the circuit. You know very well the power consumption average power is like a VRMS, IRMS, cos phi. But they're saying that power consumption at resonant frequency, at resonance cos phi R by Z लिख सकते हो, RMS को V by Z लिख सकते हैं. V you will write V square by Z square into R. I know it very well. At resonance, XL equal to XC and R equal to Z. So you will say V square by this value like R equal to Z. So it's simple सा R equal to Z. यहाँ पे आप R square लिख दीजिएगा तो value like V square by R. तो value V square by R and you want to know what is the value of R. So R will be like V square by P. Voltage square 120 into 120 divided by 16. Okay, 16 watt. So 4 into 4, 120 by 4, 30. 120 by 4, 30, 900. 900 ohm is the resistance of the circuit. Okay, say some calculation mistake is here. Answer 900 ohm. Okay. Now, a very interesting question there. One of the best questions, the सबसे अच्छी questions में से पूछा गया आपसे ऐसे वही है. उनका कहना ये है, they are saying if only L is removed or C removed, the phase difference between voltage and current remain 5. अब समझो, according to phasor diagram, if you are using R, XL and XC, okay, they are saying if this is removed, angle is 45 degree. Okay, that means at this condition R equal to XC. And if capsule is removed, XL is there, XC is there, and R is there. They're saying if XC is removed, angle is same. Okay. That means you are saying if you remove one thing, XL or XC, that means it is only possible in the case when original circuit is at a resonance. Okay. Resonance के बाद बेटा आप कोई भी एक remove करोगे तो आपको के पास circuit में केवल XC XL बचेगा. But if you are saying XC by angle 45 यहाँ भी है 45 यहाँ भी, the XL must be equal to XC and the original condition will be like of resonance condition. They want to know what is the value of IRMS. So IRMS will be like VRMS divided by Z, and you are at resonance condition. That means Z is equal to under root of R square plus XL minus XC whole square, and but XL equal to SC. So Z is equal to R square plus 0 square, and current will be like VRMS divided by R. I think they have given the value of resistance 110 and voltage 220. And current will be like 2 ampere. This is the RMS value of the current. Okay. Now in this next part, they have given some equipments. कुछ equipments दिए, उनके uses को आपसे share किया गया. Transformer is used for step up, step down. Stabilizer is used for voltage input. Any input you give, and they give the same output. filter is for ripple is removed, and rectifier is for AC to DC. The answer will be like AQBPCRDS. AQBPCRDS. Answer is A. Okay. Next, if you are giving such type of current, two currents are adding in this discussion, I will be like by the help of phasor diagram, I1 0 degree and I2 90 degree. Okay, these are two phasor. This is sin omega t, this is cos omega t, and cos omega t is 90 degree ahead of sin omega t. Done. This is I1 0 degree and this is I2 90 degree. Done. Can we add them? Yes, sir. Surely I1 and I2. Then what phasor we are going to get? The phasor we are going to get is under root of I1 square plus I2 square angle phi. Okay. Or surely tan phi is equal to I2 by I1. Now this is the peak value. जो term phasor के बाहर आता है peak value. So current की peak value under root I1 square plus I2 square है. And they want to know what is the value of RMS. So under root of I1 square plus I2 square divided by root 2. Okay. This will be the answer. Clear? Now they are saying the resonance quality factor is this. The quality factor of the circuit is given by Q is equal to omega naught L by R. Okay. Simply omega naught is 1 by under root LC L divided by R. So this value will be like root L divided by RC. Yeah? Now they are saying if L is double, resistance is decreased. So C initial value will be like under root L divided by RC. New value will be like L is double. That means यहाँ पे आपके पास root 2L आएगा. And R is decreased. That means R divided by 2. And C is remains unchanged. So 2 root 2 under L divided by RC. This is the old value of Q factor. That means new factor is 2 root 2 times of original value. Okay, Q. Original value was by 100. So you can write 2 into 1.414. Okay, into 100. Or you can write 2 into 141.4. So 282.8. If you round off this value at 283. Okay. In this circuit, they want to know what is the value of resonant frequency and peak current. So peak current आपको अगर solve करना है, तो peak current 30. These are the values. Okay. Now, if I want to know what is the condition here, Z is equal to under root of R square plus XL minus XC whole square. Okay? What is the value of XL here? Omega is 100. Okay, this is omega and this is L. XL is omega L. Omega into 100 into 10 to the power minus 3. And this value will be like 10 ohm. What is the value of XC? That is 1 by omega C. Omega is 100 and C is 100 into 10 to the power minus 6. This value will be like 100. Okay. Done. So if I want to know what is the value of Z, so R is 120 square. XL minus XC. That is 10 minus 100 whole square, 90 whole square. Okay. So अगर मैं यहाँ से बचे 10 कॉमन लेता हूँ तो 12 square plus 9 square is 144 plus 81. That is 10 into root 225. Yes, root 25 is 15. R is equal to 150. Sorry, Z equal to 150. If Z is equal to 150, they want to what is the value of current. So I equal to V by Z. 30 divided by 150 is the value. 3 divided by 15, 1 by 5 and 0.2 ampere. The answer may be B or D. It will depends upon the condition. Okay. Let's see. What else they want to know? The resonance frequency. The resonance frequency in this scenario will be like N is equal to 1 by 2 pi under root LC. Okay, 1 by 2 pi under root LC. This is the answer. Okay. Now they want to know L in this scenario is simply 0.1 and C in this scenario is I think 10 to the power minus 4. So this value will be like 1 by 2 pi 10 to the power minus 5. Clear? So you can take this term upside 10 to the power 5 up divided by 2 pi, and 10 to the power 5, if you take 10 to the power 5 root, so 100 root 10 divided by 2 pi. Okay, so answer will be like 10 to the power 5, 100 root 10. Pi root 10 cancel, and is 50 hertz. So n is 50 hertz and 0.2 ampere. You have to check the solution, but discussion is like this only. Okay, maybe some calculation mistake, maybe on these are the memory based answers. Maybe I am wrong. 2 pi under LC, I think 2 pi under LC. L is 100 milli. Done. C done. 10 to the power minus 4, 10 to the power minus 10 to the minus 5, 10 to the power 5 upside, 110 root 10 is 5. Okay. So these are the question asked in February from alternating current and inductance based questions. Okay. They asked very good questions. Some questions are very good. Quality factor is an important topic for you. Okay, according to NTA, they are asking again and again. 2 times they have asked. Okay, to focus on quality factor and AC circuit, basically resonance condition. Okay, we'll discuss other part of syllabus in other videos. Okay, bye bye.